Alright, welcome guys to part 2 of this training series, which is training considerations for improving maximal power. So just to review, as you know, there's a relationship between force and velocity, and that relationship seems to be inverse, which means that power output, as you can see on the graph, seems to be optimized at around the middle of the two. But one thing I want to point out is that there's a fundamental relationship that exists between strength and power. And that dictates that an individual cannot possess a high level of power without first being relatively strong. In fact, we can actually see this here. Bork showed that essentially, if you look here at relative strength, people who squatted more than 2 times their body weight as opposed to people who squatted less, were able to elicit greater power than the weaker individuals. We see that on the right. And then we see that here we're looking at a counter movement vertical jump, and you notice that Olympic lifters exert more force than the power lifters, and the Olympic lifters have more power than the power lifters. Now, a real good study in recreationally trained individuals, they took these individuals, they had them train at 90% of their 1RM, and they gained 15% on their strength. And if you notice here, along this force velocity curve, before and after, they gained power at every percentage of their 1RM. So with these novice individuals, just getting stronger made them more powerful at any given load. So theoretically, if an athlete could keep getting stronger at the same rate as an untrained novice through either steroid use or creative training protocols, the degree to which strength training would influence maximal power would be quite similar. Unfortunately, actually, it's a good study by Juha Ahotinen, a good friend of mine, out of Jyväskylä, Finland. And what he did was he had 21 weeks of resistance training, and if you look at untrained people, they got something like 15% increases in maximal strength, whereas trained people got around 3%. What this means is that you do have diminishing returns for strength training. This is a really, really cool study. What they're looking at is they put people on a training study that maximize more specific power activities like ballistic exercises, plyometrics, complex and contrast training. Basically, we had people who began with squatting 2 times their body weight versus people who could squat 1.3 times their body weight. The stronger group increased power output, peak power output, average power output, and jump power or jump height more than the weaker group. So that's basically the change in want. So if you have greater strength, once you start training specifically, you have a greater capacity to increase power. And again, the black group is the stronger group, and the gray group is the weaker group. Now, careful inspection of the literature suggests that athletes who squat a minimum of 2 times their body weight can express higher power outputs and have greater capacity to gain power in vertical and horizontal jumping activities. So what we think is that there's an apparent minimum back squat of 2 times your body weight. So let's talk about movement pattern specificity. Basically, the ability to generate maximal power in dynamic multi-joint movements is dependent on the nature of the movement involved. So that means that exercise selected for a power training program can influence the magnitude of performance improvements and the type of adaptations observed. So let's talk about movement pattern specificity. We have traditional resistance training, ballistic training, things like plyometrics, and things like weightlifting. So if we look at traditional training, one of the problems is that there is a zero velocity endpoint. What that means is that you might be accelerating the first half of the lift and then decelerating the second half of the lift. And that's a problem because if you're doing a sporting movement like a jump or you're throwing a ball, you're not decelerating. And so therefore, leads to the question is how specific is a normal free weight movement? So, well, the thing to understand is that traditional resistance training is vital for maximal strength, but further training-induced improvement in maximal power may require more mechanically specific movements. So here, if we look at 45% of your 1RM on the bench press throw on the Smith machine, a ballistic movement, we see that the bench press throw, which is the black boxes, they accelerate along a longer percentage of the concentric movement. Whereas you can see deceleration in the non-ballistic bench press movement. And again, it's because they're coming to a zero endpoint. If you look at force in the black boxes, force is higher along the entire spectrum relative to the white box, which is the traditional. And if you look at muscle activation, it's greater. For example, look at the anterior deltoid and the pecs. The pecs, for example, are far more activated during the latter portion of the movement, and that's very important. Why the latter portion of the movement? Because force is equal to mass times acceleration. If acceleration is going down, force will be down, and muscle activation will slow. So I want to point out a few things here. We have heavy resistance training, we have explosive or ballistic training, and then we're comparing that to untrained people. So here is maximal strength training. What you're looking at is force. Force increases over the untrained group, which is a group on the bottom. So maximal strength training increases your max force. However, if you look at ballistic training, it doesn't increase max force much, but it increases the rate that you develop force. And that's very important compared to the untrained group. So if you're doing explosive ballistic, you're going to increase the rate of force development. If you're doing heavy resistance training, you're going to increase the peak force. Again, we look at ballistic training. Again, we see muscle activation is higher. I want you to look on the lower right-hand side of this graph. Look at the anterior deltoid. If you look at the bench throw, muscle activity is activated throughout the entire lift. If you look at the normal press, notice it's activated the first half and declines the second. So again, it's because you're decelerating. This is a study in volleyball players by Newton and colleagues, and basically they had people just do strength training or they had them do ballistic training. The ballistic group gained a higher percentage on their vertical jump than the traditional. So ballistic training is beneficial. One thing I want to point out is that the intention to move explosively is critical. This is something that Louis Simmons from Westside preaches a lot, and that has been supported by Sale and colleagues in the 90s. Basically what they found is that the intention to move fast will lead to adaptation. So even if you're doing an isometric contraction, if you're trying to explode, you'll increase your rate of force development. So if you're lifting at 90% of your 1RM, you should still try to lift with maximal intended velocity. So use of lighter load conditions equivalent to 0 to 60% 1RM in conjunction with ballistic or plyometric exercises is commonly recommended and utilized in power training programs. Why? You have a high rate of force development, velocities are more similar to sport, and you have high power outputs as well. Now, one thing I want to point out, though, is that power adaptations are specific to the load. So in this study, for example, they had people train at 90% of their 1RM 5x2 repetitions, 35% of their 1RM 5x7, and 15% of their 1RM 5x10. Okay. Watch this. I'm pointing right now to the 35% condition. Notice that improvements in power were highest, at around that range, 40, no more than 50%, and then they started to decline. If you look at the 90% condition, 90% conditions changes in power peaked at the 90% mark, whereas the 15% condition peaked at the lower end of the spectrum, like 30%. So this says is that you may need to train specifically to where you want your power output exerted. So if you take the football player up to the upper right, he's going to probably want to train at that 90% zone. If you look at the hockey player trying to increase their slap shot, that's going to be closer to 35% zone. The 15% may be a little bit too low, and you may as well train at the 35 because at all points it's better. So if you're if you're a hockey player and you are both impact as well as things like slap shots, it's likely that you'll want to do is training a mixed methods approach. I'll explain that later. But again, if you're doing ballistic movements, light load training is probably ideal. Let's talk about this optimal loading condition. So optimal loads, really in the literature, is saying a specific movement that optimizes power is the optimal load. But one thing I want to point out is that will change depending on the exercise. Here you have power cleans, which is weightlifting, and in this case, that's a weightlifting activity. You have jump squats, and then we have the back squat. So traditional weightlifting, ballistic movements, and then power cleans. So if we look here, optimal power is going to depend on the selection of the activity. So if you're doing jump squats, if you notice, power is really optimized at around zero velocity. But if we look at back squat training, it's optimized in the middle there at around 40 to 60% of your 1 RM. Whereas if you look at things like hang power clean and power clean, it's optimized really at around 80 to 90% of your 1 RM. We can safely say around 80. So again, you can actually select out exercises to train different portions of the strength curve. Now, does training at the optimal power load have effects? Well, this is a study where basically they took individuals for 10 weeks, and they either had them go heavy, 6 to 10 RM, plyo group, which is drop jumps, or a max power group, load that optimized power in the jump squat. What you want to see is that the percent change in the counter movement jump and the squat jump were greatest when you had the max power compared to the plyometric and weight training group. Of course, this makes sense. It's more specific. What are you doing? You're training a vertical jump. So what's going to be optimal for training that is probably more specific to that type of activity. But if you're doing an activity like football or rugby, basically what they did was they compared power outputs at 40 kilogram loads on the bench stroke compared all the way up to 80 kilogram loads. And what you notice is that the City League is down on everything, but the semi-pro at 40 and 50 kilograms are not much different than the pro. Where they differ is 70 to 80 kilograms. What this is saying is that in sports which require power against an external load like football and rugby, we see that power outputs at greater loads are best predictors and show the greatest differences between college and professional rugbies. Therefore, in these types of athletes, it's important and critical to develop the ability to not only express high forces, but also generate high power outputs under loaded conditions. We can see that in this graph here. You have basically 20 kilograms, 40 kilograms, 60 kilograms, and 3 RM loading. And what you're seeing is that this is showing the percent difference between elite and then normal rugby players, high-level rugby players. And what you see is that the elite rugby players, their greatest differences are in the heavier weights. Great study here by Stråtegy, and what they essentially did was they had all the way to the left, you're looking at changes in power output before and after. The after being the dark line, the before being the dotted line. So you have a mixed methods approach of 30 plus 60% of your 1 RM had a 41% increase. Then you have a mixed method of 30 plus 100%, 24% increase. But the largest increase across the spectrum And the most consistent gains across the spectrum came when you combine 30, 60, and 100%. That ended up being 53% increases, which indicates that probably a mixed methods approach is ideal. We see that here as well. You have a power training group, and basically you see baselines, the closed circles, post is the inverted triangles. Notice that around body mass, 20 kilograms loaded, you see increases, but no increases at the higher loads. However, when you combine strength and power to the right, there's increases in powers across the load spectrum. So again, what does it support? It supports a mixed methods approach. So basically, we say a variety of loads is important. Well, that can always be programmed into how you're training. So, for example, say we look at the back squat. So power development might occur between loads of 30 to 70%, whereas higher loads would typically be employed for strength development. So, once you notice, you can use two orders, right? So in this study that you're seeing in the box, they had 40, 50, and 60 kilogram loads, which corresponds to P40, P50, P60 during the bench press throws. Any professional rugby players. So they either had a descending condition where they started with a lighter load, which is the 40 kilograms, lifted it explosively, then did the moderate load, 50% lifted explosively, then went to the high load, lifted explosively. That's an ascending order. In the descending order, they started heavy, 60 kilograms, explosively, and then went down to 50, and then went down to 40. So what you notice that the order that you do it will augment specifically a certain outcome. So if you look at P60, which is 60 kilograms here, the ascending order by starting light explosively potentiated the heavy loads. So you got 540 watts compared to 487 watts in the descending order. So that warm-up explosively will actually potentiate those high loads. If you look at the P40, on the other hand, if you started off descending, so you started off heavy with the 60 explosively all the way down to 40, you potentiate the 40, so 486 watts versus 439 watts. So it's always going to depend on the goal. If you're going for strength, you might go up explosively to go on the way up. If you're going for power, you might do a descending, start heavy, and go down to power. Okay, so that's very, very important to understand. This is basically showing that what they did was they lifted with submaximal warm-ups explosively with the intent to move as quickly as possible. And in this study, Young found that maximal velocity, or the increased rate of force development, was greater when you warmed up maximally compared to slow. Second strategy we can use is exercise selection. The back squat can be used to develop strength and the high force, low velocity portion of the force velocity curve. The power clean could be used to develop the high force, high velocity portion of the curve. And the jump squat can serve to maximize the low force, high velocity portion of the curve. Right, so we kind of see that here. High force, high velocity movements like the jerk, the snatch, the clean, but your cleans and your snatches can also be used to train things like the moderate to high force, the moderate high velocity movements. But if you look at, like, obviously the squat or the deadlift, you're talking about basically high force, low velocity movements, whereas the jump squat is a low force, high velocity movement. Okay, so we can clearly see that here, right? So if you look at to the top left on A, you have low load, high velocity resistance training. Then you have moderate load, moderately high velocity resistance training. And then you have high to moderate to low velocity resistance training. If you just did ballistic or explosive, you're going to increase the low load, high velocity portion of the curve. If you just did heavy training, you might increase the high load, low velocity curve. If you did a mixed approach, you're going to increase it all along the curve. So it looks again like this. Heavy resistance training, force is high, velocity is low. Explosive training, force is low, velocity is high. Mixed methods, force is high, velocity is high. And you get the best of both worlds. Plyometrics are, again, jumping and bounding. You're trying to work the stretch-shorten cycle. And similar to ballistic exercises, plyometrics are theorized to elicit specific adaptations in neural drive, the rate of neural activation, and intramuscular control, which result in an improved rate of force development. As far as your repetition schema, it's likely ideal to keep repetitions in a 1 to 5 rep range. You can sort of see that here, that if you look at power output, you go from 544 watts to 558 to 571 to 558 to 561. Then we start to descend after the 5th rep.